Hello everybody, Elias5891 took a wrong turn today, but that's okay, he's alright. He left me in charge. So filling in, it's Timwe with another KTANE module tutorial, and today we're going to look at a module called Left and Right. Let's go straight into it. And here is what the module looks like. It has two buttons, one of which is green, one of which is blue, and they may be in this order or that order, so they could be in either order. The important information that you need to obtain for this is edge work related, so let's take a quick look at the manual. Determining the correct sequence. There are a few conditions here that we need to go through, and I'm going to go through these in order. So let's take a look at the last digit of the serial number. That would be a 7. Okay, so the first digit is the last digit of the serial number, which is 7 cubed. So 7 times 7 times 7, which is 343, and then modulo 8. So it's still 7. So our first digit is a 7. If there are more or fewer ports than there are port plates, that's just another way of saying if the number of ports and the number of port plates are different. So let's find out if that's the case. We have 2 ports and only 1 port plate, so they are different, so that's a yes. Then the next digit is the number of ports, which is 2, plus the number of plates, which is 1, so 3, to the power of 4. So you're on 3 times 3 times 3 times 3, and then the whole thing modulo 4, and that is a 1. So the next digit is a 1. So we skip this because that's an otherwise to this if. So if this were false, you would do this instead. So the next condition is if the number of batteries equals the number of battery holders. Well, let's find out. We have 4 batteries in 4 holders, so they do in fact match. So that's a yes. The next digit is the number of lit minus unlit indicators. That would be 0, because we don't have any indicators at all. And then obviously if you square that, it's still 0, and modulo 6 is still 0. So we have 710. That is the number that we start with. Now, in order to proceed, we need to convert this number to binary. And I'm just going to use the Windows calculator for that. The binary equivalent of that number is this. Alright? So convert this number to base 2. This new number is your sequence. A digit 1 represents the right button. So let's use some search and replace here to change the 1 to R and the 0 to L. So these ostensibly is the sequence of buttons that I need to press. Right, left, right, left, 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 right, left. But actually that's not true, because there is a plot twist. Whenever a button has been pressed a number of times, they switch, which means left becomes right and right becomes left. So to find out at which point they switch, we go through these conditions. Let's see, do we have more lit than unlit? No, because we have 0 of each. Do we have a vowel in the serial number? We have an India and an echo, so yes, we do have a vowel. So we have a number 2. Now this is the first number that we found, which means that the green button, which in this case is on the left of the module, in fact, I'll just write it down like this. So green is 2, and then for the blue button, we keep going and see what matches next. Battery holders, which was 4, plus port plates, which is 1, so 5, plus indicators is 0, still 5. Yes, that is less than or equal to 5, so our next number is 4. Alright? Now, for those modules where green is on the left, I'm gonna write down both. For those where green is on the left, this is the left, this is the right. Otherwise, this is the right, this is the left. I'll swap those two. So let's first look at the case where the left button, the green button is on the left. So we would press the right button, and that would be the first time that we press the right button. So I'll write down a 1. And then we press the left button. That would be the first time we press the left button. Then we press the right button again. We've already pressed it once, so that would be a 2 and then a 3. And then we start counting with the lefts again. 2. But now we've pressed the left button 2 times. At this point, left and right switch. So I'm going to change all the L's to R's and the R's to L's here. Now, if we press the next correct button, that would be the right button. And because we've already pressed the right button 3 times, this would be the 4th time. So here we switch again. Left, right, right, left. So the next button is a left. Now the last time we had pressed the left button twice. So now this will be the first time again after the last count. So the count resets. Alright, same for the right button. This is the first time, then the second time, and then this is the second time we pressed left, but we don't care at this point because there are no other buttons left to press. So this is the correct sequence for this module now. Okay, so let's put that in. We have right, left, right, right, left, right, left. Now imagine at this point you lose track. Helpfully, the module shows you the sequence of button presses that you've already done. So you can always ask, the diffuser what's already on the display, and you can resume from there. So after this left, we have right, right, left, and that's it solved. So for every module where green is on the left, this will be the exact same answer. But for the ones where blue is on the left, the answer will be different. So let's go through that now. I'm going to use undo in my editor here to obtain the original list of the original sequence. So in this case, it is this set of numbers that matters, which means that now we switch after the second time we press the right button. So let's start counting. This is the first time, this is the first time, and bang, we're already pressing the right button for the second time here. So now we switch over all of these. And now this is the second time we press left, but we don't care because it's only after 4 presses that this matters. Now we start counting the rights again. 1, 2. Oop, that's the second time we pressed right. So we have to switch everything up again. This is the third time we press left. And then another first and second time. So this one still has to be switched. And then that's the first time again. All right, so now our answer looks like this. So let's try that. That would be right, left, right, left, right, right, left, right, right, right. And again, it's the same answer for every module where the buttons are in the same order. And because the answer is displayed on the display, you can even literally just read it off the display and enter the same answer in another module, and it's solved. Okay, here's another bomb with different edge work. Let's see if we have different conditions this time. So let's take a look. The serial number ends in a 1. So the first condition, the first digit is the last digit of the serial number cubed. So 1 cubed obviously is still 1, modulo 8 is still a 1, so it's a 1. If there are more or fewer ports, a different number of ports than port plates, that's a no, because we have no ports at all, so it's 0 and 0. So we go to the otherwise this time. Otherwise, the next digits are the number of D batteries, which is 1, followed by the number of letters in the serial number. Okay, so it's a 1 followed by 4, because there are 4 letters, all right? If the number of batteries equals the number of battery holders, that is not the case, because we have 5 batteries and 3 holders. So we go to the otherwise. The next digits are the sum of batteries plus battery holders. So since we have 5 and 3, the sum of that is 8. So now our number is 1148. That's a relatively big number. So I'm going to convert that to binary again, and this time we get this sequence of zeros and ones. And as before, a 1 represents the right button. So 1 is right, and 0 is left. So again, this is the initial sequence, which we will need to modify. So let's take a look at the plot twist conditions. Are there more lit than unlit indicators? Well, we have 2 unlit, so that's a no. Is there a vowel in the serial number? Yep, we have an echo. So again, the first number is 2 for the green button. And for the blue button, do we have battery holders? Alright, battery holders are 3, port plates are 0, and indicators. So if you're playing standard missions with vanilla widgets, then this condition is always going to be true, because you're always going to have 5 widgets. So the only way to get this condition ever be false is to use like the bomb created to have more than 5 widgets. So blue is a 4. Okay, so let's take a look. This is the only module where green is on the left. So I'm gonna start with this one. So if green is on the left, then the left button, then the buttons switch after 2 presses of the left button and 4 presses of the right button. So let's count. 1, 1, 2. There's our first switch. This time I'm going to take a copy of the original sequence so that I can reuse it. So now we switch it all around. Then this is the second time we press right, but we don't care. 2 presses of left and we switch again. And that's our third press of the right, and here is our fourth. So here we need to switch over again. First of the left and then 2 of the right. Doesn't trigger again, so this is the answer. So let's put that in. We have right, left, left, right, left, left, right, right, left. Now let's say I make a mistake. I'm gonna press left now, even though it's wrong. As you can see, it does not reset. It wants you to continue the sequence where you left off, and you can just finish it. So the answer doesn't change. The buttons never switch around either when you get a strike. So you can just continue and finish the sequence. Alright, so now let's see what we get if the right button is, if the green button is on the right, then we get this. So now, after 1, 2, 3, here's the second right, so we switch over here. And then this is the fourth left, so we switch over again. And then here we start counting the rights again, so here we switch over. This is the first left, and then the first and second right. So there would be another switch here, but at this point we've solved the module, so we don't care. Alright. So we go right, left, 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 right, left, right, right, left, right, right. And it's correct. Right, I hope that this demonstration has shown you how to play this module. What I've shown you is my strategy of how I solve the module. There are tons of other ways of solving this module. If you find ways of optimizing this mechanism in a way that is more suitable to you, then more power to you. That's great. If you have any questions, comments, concerns, or suggestions, then feel free to leave a comment here in the YouTube section or drop me a line on Discord. Until then, I'm going to see you again, and don't explode. Goodbye.